All right, everybody. Welcome back to the channel. Welcome back to the stream. Sorry if I started the stream a little later on Twitch. Ran into some technical difficulties. That's going to take a little bit of time to completely work out, but it should. We should be able to at least get through this stream, and I'll work on getting the rest of the stuff worked out later down the road. So today we're going to build the pilot board. I may not be able to show everything. Some of my setup's not working exactly the way I wanted it to. I'll do some more testing down the road and get things working better, and just better overall, and we can do better and be able to showcase more stuff. But at least we'll be able to build the PCBs. So I've kind of got like a little webcam set up. I'm going to be working more trying to be able to use my phone to be part of the stream recording process, and that way I can be a little bit more mobile and show more of the processes and everything that's going on. But for now, we've got what we've got, and we're going to be working as best as we can. So if you like what we're doing, enjoying the channel, enjoying the content, definitely like and subscribe. Hit that notification, that bell icon to be informed of anytime we drop new videos on YouTube. So let's get into it. So we're going to build our pilot board. If you're in the stream, I won't really be able to monitor chat too well because of my setup right now. Again, trying to get things going and getting things organized the best we can. I'm going to apologize for any helter-skelter camera work. It's going to be as best as we can, but the main point is just to kind of showcase the process and move along. I'll do my best to have the imagery, the images look as good as possible, and everything, work out good in the long run. But we'll just keep kind of moving along and improving the process as we go. That's just the way it works. So I got code open here. So one of the things I did was I took the BOM, kind of hid the unnecessary columns, because all we really need to know are the references, the quantity, internal part number, and maybe the manufacturer part number if we need a cross-reference. And I printed this out, so I've got a physical copy at the workstation just to make it easier. I've got to figure out how to make effective documentation through KiCad, something like assembly documentation. I'll work on all that down the road. We might have to go through and spend some time together and update the part libraries to do better, to get better assembly tools or assembly diagrams and stuff for documentation. But we'll work on that as we go. Like I said, KiCad's new. Circuit Studio and Altium Designer, they've got some really, really solid documentation tools. Altium Designer being the best as far as drafting up all your assembly documents, your fabrication documents, and all that. Circuit Studio at least has some more functionality built in for printing out assembly diagrams. KiCad's a little bit more difficult, got to jump through a little bit more hoops. But we'll get something set up. We'll set up a process that actually works through KiCad. Because like I said in the other day, yesterday, that I want to do that other project, that sub-project for the fan test fixture. And we'll go from there. So I've got this printed out, ready to rock and roll over there. I also want to say that I found the wire around nice 200 watt 50 ohm potentiometer for the test rig for the loading test. So this should meet all of our needs for power and variable resistance. So we'll be able to build the test fixture, and for the deep testing, set that up with the proper documentation and everything of how to set it up and configure it. So that'll be good. What's nice is it's a complete kit, and the fact it can handle 200 watts. So that'll definitely serve as a good power sinking power resistor for what we're doing. I think I'll be getting it in on Monday. So tomorrow's stream, maybe just general testing on the board, doing the initial testing. No deep testing till we can get some of this other stuff done, but we can do the power-up testing because I think today's pretty much going to be taken up on doing all the assembly, the SMT work as well as the through-hole work. So I'm going to switch over to the webcam. Again, forgive me. It's not the best. I'll be doing some fidgeting, some adjusting. Hopefully trying to show what I want to show. But maybe be switching over between other cameras and stuff. We'll see. Because I've got my phone. I've got an older phone that I'm using as a webcam. An IP-enabled webcam, but it likes to flicker. So I'll try to use it, and we'll go from there. I'll try to do my best not do the flickering. So I'm going to go and switch over to the other webcam. So, without further ado, I'm going to make some adjustments again. Sorry, I'm not trying to make anybody sick or anything, but okay. So the work area, I've kind of printed out something to help me locate placements if I need it. Wow, it's really showing some weird color band or light banding. Let's turn that off. Wow, this camera is not liking some of this. A little bit better since I shut that off. Turn the light brightness back up. All right. That might be a little bit better. Again, I apologize. We'll be working out the kinks as we go. So, yeah. Okay. So this will be like kind of an assembly reference if we need it. But honestly, it won't be very helpful. I'm going to have to work out a way to make this stuff better for assembly documentation, but we'll work on that. So I'll set that aside. So here's the BOM, again, printed out, so I have my references, so it's just easier for me to reference. And before we get too far along, I want to show you, so the switch box I was talking about that I designed real quick for the real quick test button. So that's it in its glory. I've got the rectangle cell switch because I had one laying around that I can use. 3-conductor cable with sufficient wire length to be able to jump between the power supply and the PCB assembly. So that's basically all that is, the button heads. That's all it is, just a little safe spot to help hold the switch in place. Nice satisfying click sound. You want like something like a fidget toy. This would be great for, because it kind of resonates in the box a little bit. So I'm going to attempt to switch over to the actually no, first let's get some things kind of organized here. So I've got the BOM over here. I've got my box of parts beside me on a side table. Again, my workstation and my workshop is in flux. Still organizing, cleaning, and getting things set up. Have our PCBs. Again, sorry about the reflection. These are extremely reflective. So we've got our PCB. I've got my box of parts here. So the good thing about doing the solder, the SMT, we can kind of take our time. We've got about an hour and a half of work time on the solder paste before it actually has to be flowed. So we've got, we don't have to rush the process. So it'll give me time to go through the box of parts as we go, set things aside that aren't needed for the board. So what we're going to do is we're going to populate the bottom first. So typically a rule of thumb that you want to do your best at following when you're doing PCB assembly work. You'll hear differences of opinions on this, but this is from personal experience and just years of doing this. So you want to look at the side of your board that has the least amount of silicone on it. Basically, the least amount of transistors or high-end ICs. Now, the bottom, we have the RS-45 transceiver, but I wouldn't consider it a super high-end IC. And in fact, I don't even think it has a moisture sensitivity rating. I think it's just 1. So I'm not too terribly worried about it. So you want to kind of populate and reflow. Well, and then there's also that transistor, but that's fine. You want to kind of populate that and reflow it first. And then what you would consider your more silicone populated side, or the side with your more expensive higher end silicone components, such as like microcontrollers and stuff, you want to basically reflow them only once. Because what's going to happen is you're going to populate the bottom side, reflow it, so that's going to run it through one heat cycle. Basically increase the temperature, hit reflow temp, and cool back down, and then you're going to populate and build the top side, which forces these components on the bottom to go through a second heat cycle. So you want to try to avoid that with higher end or more sensitive silicone components. So that's why we're going to populate and do the bottom first. So the first thing that we'll need to do is grab the bottom stencil. Actually, let's try this with this webcam on the phone. Let's try it. So the problem with the webcam on the phone using the IP camera is it would flicker sometimes, and I don't know if that would become annoying, but we're only going to use it for a few things. So I'm going to switch over to it. All right. Let's see if we can refresh it. There we go. All right. So I'll kind of give you a little bit of a better view of my setup currently. Again, apologize for any of the mess. So that's the upside down. There we go, right side up. Reflow oven. We'll cover more of that. Heat sealer for the bag. My ring light webcam setup for the view down. I'm not noticing any of the flickering. It's kind of weird now that I'm actually streaming and recording. It's not doing any of the flickering. Maybe it was just me being crazy and dumb, which would be fine. Because if that's the case, then I can use the phone from now on and stop using that corded webcam for this. Oh, nope, there's the flicker. All right, so what I'm going to do is then speed up a little bit. My soldering workstation. Nice little Pace ST50. And then the stencil printer. So I have no easy way of doing this with one hand. So I'm going to set the phone down. And unfortunately, I have to kind of do some stuff. You get to stare at the soldering stuff real quick. Again, I'm going to need additional stands and holders and stuff and things like that. So I'm going to grab the SMT stencil out of the box for the bottom side. And that's why I do all the part numbering that I do. So we're going to get it loaded up into the stencil printer. Don't have to worry about centering the stencil too much in the printer. Grab my phone. Try not to touch anything on the screen. Sorry about that. So I don't have to worry about centering it too much or torquing down all the holder clamps. So it's got the counterweight. When properly adjusted, it helps hold it up, and then doesn't take much to really lift it and lower it. So that's what's nice about this, and a lot easier than the method of trying to use PCBs to create like a frame to hold one of your, and then those little small stencils, and try to tape everything down and get everything to stay in place, and then you're fighting it. So this is going to be the most time consuming. So here are the jigs. So we're going to have to kind of pull these out, and we're going to have to kind of play a little bit of a guessing game of where they're going to have to go. So the initial setup is going to take the most amount of time. Yeah, that's why I'm going to need another phone stand or something, or a camera stand to hold this guy. If I can solve the flickering, or maybe use my new phone or something. Because I was trying to repurpose an old phone, and flickering is happening. It's just not as often. I don't know if it's because I'm actually recording or what. Yeah, I'm definitely going to need to get more stands for doing this. So these are the jigs. Well, the jigs. So it has that little pin that, for one thing, there's different diameters of pins. This happens to be 3mm for the 3mm holes for the M3. And then you adjust the height. So this set screw, you back out and you can adjust the height of this guy to basically, you want to be below the surface of the PCB so it doesn't interfere with the stencil, but be tall enough to actually grab the hold, the actual board to hold it in place. So I don't know if you can see this very well. I see my horrible reflection. So those are the larger resistors for the optos, and they're right here on the board, so we need to make sure we have the orientation like this. So this is going to be difficult to do with one hand, so I'm going to kind of get it slightly adjusted, and you can stare a little bit at that for a little bit while I do this again. Not perfect setup. It's going to take time to get everything set up, and, you know, because I have to invest in everything I need to do this properly. So just kind of get this guy kind of placed, kind of get an idea here of where I am. This stuff needs to go up a little bit more, it looks like. All right. Looks like a hole, a threaded hole. There's a threaded hole there. Too far up. That's good. It's good that we're too far up, because it looks like I can start using some of these holes. So we're not going to dial in perfect using these the actual jigs to hold the board. We're going to get as close as we can, and then I'll show you the adjustments on the I don't have to go over here. It looks like, yeah, probably here. We can adjust the stencil a little bit if we have to, kind of back it out. We'll find the threaded. Might be helpful to go through with a tap and thread more of these holes in here. I might just do that one of these days to give more mounting options. Yeah, this is really half the battle with this, but once you get dialed in, get it really, really there, it becomes a lot better than trying to fight a PCB with trying to make a frame out of other PCBs. All right. Oh, we need to be as close. So there's the holes. So I need to come back just a little bit. There we go. Start. All right. Okay. I think this will be close. And then that's where the fine-tune adjustments will come into play. So, oh, that's pretty close. All right. Again, sorry for any flickering. So, basically, we'll have it close. And then we'll have these fine-tune adjustments here to move it forward and backwards. And then there's 2 on the side to left and right, and then also handle the skew that way. But once you get it dialed in, it only takes minor adjustments as long as you don't move. Okay, that's moving it too far forward. All right, so that moved those guys back. Just basically eyeballing the gold here. That's one of the reasons I like gold Enig, because you can actually clearly see it through the stencil. I don't know how well you can see that, but we've pretty much got proper coverage. Might have to kind of just that. All right, beautiful. So my other phone's wanting attention, so I'm going to set you down again. Put my other phone here out of the way. All right. So we've got that guy set up. Now I'm going to switch to the other webcam real quick. Hide that. Go here. Sorry for all the transitions. Again, we're learning. We're trying to do the best we can. So here is the solder paste. No clean, lead-free. I'm going to kind of pull this up a little bit. Sorry. All right. Tighten some thumb screws on this guy, but hey. So this is the basically like an icing knife, but you know, it came with the stencil printer as a complete kit. Then we also have this guy, kind of too big. This is the squeegee for the solder paste. Nice, clean, solid edge to it. And then it's probably going to be a mistake, but hey, I got to grab stuff. So, and then the stencil wipes I was telling you about. We're going to go ahead and grab 2 wipes. I don't use the feed through because I don't use the wipe fast enough, and I always take from the outer side of the roll. Because they don't dry out as fast. So one of the things I'm going to do is just wipe down the tools real quick because they have been sitting. Don't get any dust off of them and to clean anything that could be on them. And I'm going to take one of them and just kind of go over the top of the stencil because all my fingerprints are on there. And that's fine. Give everything a chance time to dry. So I'm going to keep these 2 guys handy because I'm going to need them. They won't dry out that fast, so I'll keep them handy to the side to help wipe things down. So while things are drying, the only problem with these wipes is they're not lint free. So that's one thing I don't like about them, but it's fine. They're made to clean up the flux and stuff, so. All right, so grab my gloves. mainly because this phase is a little bit messy. So trying not to get my phone all messy either. So while things kind of dry, I'm going to pop the cap off the solder paste. Oh, look at that delicious cake frosting. Delicious silver cake frosting. And good thing you can't smell it. It smells so good. So one of the things you want to do is you want to stir it. You want to try to get it nice and mixed. That way, because it will separate, the solids will separate from the liquids. You want to try stirring it for, 30 seconds to a minute to get things blended. Kind of like cake frosting, or frosting for cookies or whatever. Wearing gloves because this can be pretty messy, this part of it. Just kind of mixing it. Blending it as best as we can. And it helps. Yeah, there we go. Just making a mess all over my work surface. But hey, that's fine. That's fine. Plus, it just helps kind of work it and get it like loose. Kind of kneads it. Makes it a little easier to spread. All right. So everything looks like it's dry enough. Set this guy aside. And switch over to the other camera. Again, sorry for all the switching, but it's what we've got. Turn that guy off, turn that guy on. Oop. Aha, we're alive. Transition here and show you what we're going to do. Make sure there's no debris all over there. So, I'll do this first since I have no way of holding the phone right now and doing this at the same time. Not only with the cleaner on there, but the electro polishing, the coating that I have done to the stencils actually make it hard to stick paste to them to even get the board pasted in the first place. All right. I'll show you what I did and then what we're going to do. Put that guy aside. Now, so webcam. Okay. So we put a good old blob of, we just left the stencil wipes there, no big deal. They're not in the way. So a good old blob of solder paste. Again, that's why I like the jars. It's easier to get out and you could reuse this. It's a big enough blob. That way you can ensure that you've got coverage. So you're going to take your stencil, your squeegee, try to center as best as you can. Apply moderate pressure and just drag it towards you. And that will, so I didn't get all the way down, that's fine. I can come back here, apply moderate pressure. All right, set this guy aside. Clean up the mess later anyway. Lift the stencil. And we'll look over the board. So what I'm going to do is I'm going to switch again to the other camera. Again, sorry for all this. I'm going to pull the board out. Switch to the other camera, which we should be able to stay with for a little bit longer. Like that. Turn that guy on. There we go. Now, before we put the paste or everything away, we want to kind of visually look at the solder paste. Look at as best as we can. Kind of make sure it's a little bit off pad, but that's fine. It's not too far off. It'll be fine. It'll flow. So that looks good enough. It's a little bit off pad, but that's not enough to be a concern. It'll be fine. It'll flow. It'll basically center itself once it goes liquidous. All right. Yep. Q7, which is the double transistor. Looks like it's good. All right. So we'll set that aside. Let's kind of clean up our mess here. So this might actually end up being a longer stream than normal and a longer video because of what we're doing, because I at least want to build the top side, at least do the full SMT work and try to get the through-hole parts put in. But that's fine. It's a weekend, it's Saturday, and this is probably one of those things that viewers and everybody's been kind of excited to see. So got that cleaned up. Now, again, you have work time with the board. So I'm making a mess here, and that's why I'm wearing gloves. Get the lid back on the solder paste nice and tight so it doesn't dry out. Drop the thing a little bit. Grab one of the wipes. Start cleaning our tools off. Get all this excess paste off of them. Get the squeegee cleaned up. Even though we will be, pasting and soldering the top, workstation cleanliness is important as best as you can, and this paste will slowly dry because we still have to not only place the parts on the bottom, it won't take as long, there's not as many parts, but we also have to reflow it and let it cool before handling it. Because trust me, that puppy comes out of there really warm. So got that guy clean. I'll set the stencil down to dry. And then kind of clean up the mess on the my little surface here before it has a chance to dry and become all crusty on here. That's really fun. Clean it off the container. Yeah. See, I don't know if you can tell how saturated these cleaning cloths are, but that's why I keep that container the way it is. I don't use the easy dispense method or anything, so they don't dry out as fast. Because right now I currently don't run through them that fast, but I'm hoping that changes in the future. All right, so this guy's good. That guy's pretty saturated. So something else I want to show you before I flip over. So something else I have that I found to be useful is an old, one of my old toothbrushes, Sonicare toothbrushes or electric toothbrushes. Brand new head, obviously. It's funny, but I'll tell you what, this thing works great for cleaning the stencils, because with the soft head, it's gentle, it's not going to damage anything, and then the movement, like whatever electric toothbrush is out there, the motion helps get in there and really clean the fine orifices out. I'll switch back over again. Apologize for the way this is done, but here we go. So grab the camera, make sure I've got the right orientation. So now back to the stencil. Use a fresh wipe. Wipe up all the bulk that we can. I could have squeegeed a little bit, put a little bit more pressure and not left as much of this behind, but that's okay. It's getting close to needing to be replaced anyway. So we got that side. What we're going to do is come to the bottom side. That's another reason I like this stencil printer, is it can hold. Yeah, like I said, it leaves pieces of lint behind, but that's okay. So what we're going to do then is we're going to kind of saturate from the cleaning cloth. Grab our toothbrush. It's going to make a little bit of noise, but hey. Kind of come through, yeah. Again, it's gentle enough to get in there and not damage the stencil, but it's powerful enough to get in there, and that, the motion, especially with this, the vibration, really helps to get any solder paste out of the orifice, the fine orifices. definitely worth holding on to or picking up one from, your favorite store. Kind of wipe off the excess liquid. That's fine. It'll eventually dry. Not too worried about the lint because once it dries, it's kind of easy to shift off with your, just to kind of peel it off. Even with the dry toothbrush will kind of knock that lint right off. Because you want to try to avoid getting that into your solder paste. So one of the reasons I like the electropolishing on the stencils is just how easily they clean. So you have the breakaway from when you pull it up from the board. It cleanly breaks and you have nice square set that guy down. You have nice square, nice clean solder paste left behind. No muss, no fuss. So that's one of the reasons I really like it. Done with the solder paste for now, so get rid of these gloves. All right. So I'm going to switch webcams again. Sorry. Yep. You get to see more of my workshop, my office. Or not my office, my workshop. Okay, go back to the USB webcam. And I won't need this guy until we're ready to really do the top. Now it's time to real quick. Workshop towels. We're going to kind of get that off of there, off the building, off of my little mat here. So down the road, I want to get a big ESD mat and place it here. That's my next goal, one of my next plans. Get a nice big ESD mat. All right, that aside. Now, board. So, like with anything else, when doing this kind of work, let's see if we can get this a little bit better. All right. Oh, really? You're gonna fight me now? Yeah. Okay. All right. Okay. A little bit better. Again, sorry for the reflection of the ring light. So, idealistically, it's going to be easier to start with the smaller components. For one thing, you won't be fighting as much. Good pair of tweezers is always a must. Kind of move the board out of the way. So, really good set of tweezers. You can get them good fine points to grab parts. Find a good kit on Amazon or whatever for this to work. And believe me, you can go and buy really expensive, really fancy tweezers. So it's time to start going through our bag of parts here. Should have separated through hole parts. I don't have an empty bag in there. Set that aside. Don't need that right now. Those are switches. I know those are tops. 50K ohms. All right. So RC. All right, 50K. So this is where the fun begins. Sometimes it might be easier just to find parts on the bottom and dig them out of the bin. So Q7, we know it's that the transistor. So go through the box of parts. This is where it's always more entertaining too. Is find the part in your bin in your box. So we got to find that transistor. Temperature sensor. All right, here we go. So here we go, our first part. And it's hard to say super organized with this because of how many parts you actually have to go through. That's why a pick and place machine is ideal. So I'm trying to do everything on camera, but there we go. Come on, tape. All right, that's that little transistor guy. That's little Q7. So now we have to find the polarity. It's going to be lots of fun. Let me grab my magnifying lens. So I've got like a little lighted 10x magnifier. I don't know if I showed this to you guys yet. So we know pin 1 is right there where that line is. I don't know if you can see it, but there's a little in the silkscreen line. Find pin 1 out of the transistor here. And it should be that guy. Yep, that's pin 1. I don't know. Yeah, this camera can't even focus on that guy. It's too... yeah. So that's another thing you're going to face is when you're dealing with smaller parts is trying to find your polarities and stuff. So pin 1 is indicated by a very small dot printed on the part. So that looks good. I'll check under the magnifying lens. I need to bump it down just a little bit. Once you get the smaller parts done and out of your way, life becomes easier. R20 and R21, I bet you those are the 10K resistors. Yeah, 0603 10K. So I'm going to take the transistors. Now I could have totally curated all this and set all this stuff aside and had everything all organized and ready to rock and roll, but that's not fun. Would have made for a nicer stream? Probably. So I'm going to go find my 10K. Okay, I know I'm going to need these at some point. Those are the resistors for the so I need my 10K. Boom, 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 boom. Here we go. 10K. R20. Okay, there's a bunch. 20 and 21 because they're pull downs. R0603. 10K 2075A. Okay, part numbers match to the bomb. And there's a bunch of them on the board. So hopefully most of them are on the bottom and we can just go ahead and place them. But I know those two are. Now these are 0603. I probably could have went 0805. Yeah, I'm hoping to maybe head towards getting a pick and place machine by the time I go into production with this stuff. Either I'm looking at an open source one, making an open source one based off of OpenPNP, or trying to find a way to get something like a Neoden or something small. I should have flipped this over to the gray side because I don't know if you can see this. Black chip resistors on on a black pad are just very difficult to see. So these are 10K, 20 and 21. Don't have to worry about too much of it being centered, because when the paste goes liquidous, they kind of the surface tension will kind of pull them. We will have to make sure, but that's we'll double check once we get everything placed. 9, 10, 11. Okay, now those I think are 1K. Alright, R4 is definitely a 10K. So R4, which is right over here. Again, I'm trying to keep everything on camera. I'm doing my best. And I'm sorry I get quiet. It's just I tend to get extremely focused when I'm doing work like this. smearing that guy all over the place. All right, R4, R20, R21, R23. Is that down here? There's 23. There's 24. There's 30. 23, 24, and 30. All right, so 3 more. Whee. Right. R9, R10. Oh, those are 10K. 11, 15, 16, 17. So, okay, 1, 2, 3, 4, 5, 6. All right. Pull out 6 more resistors. Yeah, again, trying to do everything on camera, but I know some things aren't. I apologize. Also apologize if you hear background noises. Wife's taking care of things around the house while I get to be lazy and build PCBs. Don't let her hear that, though. Flip over the resistors. So I'm flipping over the resistors to stay consistent. Now, technically, it's not an IPC violation to have a resistor upside down. As long as it's actually soldered properly, it's on pad and everything, it meets all the other criteria. So being upside down is not a violation of any kind, but it could indicate a process control problem. So that's stuff to keep in mind. Okay, so that's these guys. R22, is it? All right. Okay. So I think that's all of them. I'm not going to put this too far away in case I missed any of these resistors. I'll put them back in the little plastic baggie and set them to the side while I pull out grab a few of the other parts. Let's see here. So our, 6, 7, 8. So these guys right here are 14. I already know what ones those are. They're the 1210s. So they're going to be the 1210 1.2K. And let's make sure I'm going to see 1210 1K2 200 double AC. Yes, sir. That's what these parts are. So these are the nice big ones. And we need 6 of them for the optocouplers. Bigger the part, the much easier they are to place. Now, I had plenty of space on this board. We could have went with larger parts. There's no reason at all that we had to go with 603. We could have went 0805s. But why? Because there are other projects I work on that have 0603 because of their size, and it's just be easier. Sometimes it's easier to stay consistent in design. Basically, for inventory, it just makes it easier for controlling your inventory, and it's cheaper. Because again, it comes down to the bulk purchase rules of parts. If you can buy 2 reels of 0603 versus 1 reel of 0603 and 1 reel of 0805. sometimes the price difference, the price breaks make it worth just staying to 0603. Again, passive parts like resistors and capacitors, these chip guys do not have polarity, so I don't really care about orientation like that. That's not a violation either of any IPC rules or standards. So that doesn't really matter. Only matters for the human side of things. Yeah, this stream and this video may be a little bit long because of all the things we have to do to, you know, we're not even done populating the bottom side by hand. And we still got to reflow it, cool it, and then populate the top side. Okay. Let's see if we can find R5. R5, and it's an 805. 805, 1211. 5. An 805. I do know that much. See if I can find it in this box of parts. Wish I didn't. No, there's an 805 right there. R5, 805. Nope. Set that aside in case I need it later. Set that aside. That's external part. That's an external part. Through hole. Through hole. Yeah, see, I could have went with a simpler build and had a smaller bomb, and we would have been through this. Let's see. All right, R5, 805, 1211, 50 AAB. All right, we found you. Okay, 120 ohms. And you're double bagged. That is fascinating. That's fine. I will keep the unlabeled inner bag for a... All right, now here we go, trying to get the initial tape off from the first part. All right. That's always fun. That's R5. So that guy goes... R5. Okay, I see what that one is. That's a 120 ohm terminating resistor for the don't tell me I'm not organizing myself right here. Okay. R26 and R27. Let's go and get those guys on there. I think those are the 805 R2075. Yeah, these are the 0.2 ohms. Yeah, 0 R2, 0.2. 0 R2, yep. Yep, so these are the current sensing resistors for the stepper driver. Put these guys in place. Come on, stop being stubborn. All right, so current sensing resistors. We're getting there. We are getting there. They'll definitely be set aside because they won't be used anywhere else on this board. No. R22. R22. 0603 1K. That's the 0603 1K. All right. That's it. 1K. R22. Make sure I'm back on the right track. RCO603. 1K0075AA. Make sure we're using the right parts. Grab you out of your little baggie. All right. Okay. So let's get you out of there. Flip over, little guy. Flip over. Hey, why don't you flip over? There we go. Come on. R22. Get you placed. And then R31, are you on the bottom too? Nope, I must have you on the top. All right, so I'll set you aside because I know I'm going to need you again down the road. Or in case I missed it. All right, now the resistor R18, it looks like. That's the 22.1K. So it's 0603 22K 1075AA. Grab you out of your little bag. Yay! So much fun we're having, aren't we? Yeah, half the time spent is fighting to get the first few parts out, but once you get that tape pulled back, it gets easier for the next build or the next part of this next leg of this journey. And there's only one of them, so I can get this guy bagged up and put back aside. All right, now pretty much back down to just capacitors, or down to capacitors, a couple more pieces of silicone. So 17 and 16. Bomb. CC0805. So let's find chip capacitors in this mess. Okay, those are more through-hole parts I'll have to worry about later. All right. More silicone in here. Let's pull these guys out because oh wow, okay. Good thing I had to look under everything because I would have missed some of this stuff. Okay, 0603, 0603. Okay, that's an 805. Is that is that the part I'm looking for? 0805 226 025AA BX5R. Yes, it is. There's only two of these guys. Hooray. Make things a little bit easier. Sometimes these embossed tapes are a little bit harder to deal with than the paper tapes. It really depends on what's in here. There we go. There we go. It's all the way over here. Looks like I went bowling. So it looks like it kind of bowled and smacked the transistor setup here. So to kind of fix that, I'll look under the magnifying lens and fix that. bowling, capacitor bowling. That's quite entertaining. It's definitely weird and different. Doing all this on camera like this. Oh boy. The video stopped. I don't know why it wants to stop. I apologize for that. Freezing. It looks like it froze on me. Webcam. Yep, it froze. It froze for some reason. Fortunately, not too far ahead, not too far behind. I don't know why it wants to do that sometimes, but yeah, I was trying to fix this, the transistor setup there, and after I went bowling with a capacitor. So C15 is a 104. Woo! Again, one of the most commonly used capacitors, the 100 nanofarad. 0603 104. Here we go. And that's why I bought 200 of them, because boards consume these. These are consumed like water in designs because of how useful they are and other functions for RC timing networks and stuff. For like the enable pins on the ESP32 and like PICs and stuff for their master clear lines. So I know there's going to be at least 2 on the bottom, so let's start there. So that is what, C15? Yes, sir, it is. Boy, this is going to be tight. I should have done this guy first before those big guys, but we should make it work. Yeah. We'll nudge and fix things before we actually go start, make sure we're still alive. All right. How about 18? Looks like I missed a resistor. That's fine. So how about 18 and 19? 18 definitely is 104. Boy, this is going to be tight. See, 19. Okay. So I'm done with these guys, but I know for now, for the bottom side, the top side is going to have the lion's share of them. All right. So C19 is a 0603. Okay, that's a 22. That's an 0603 22 microfarad. It looks like 603. I think this is it. Okay. Yep. C15. No. C19. 603 226 010 AAB X5R. All right, so that's the parts I had ordered from DigiKey. That's a weird little. It's not even a baggie that I can reseal, which is fine. That's why I'm not going to open it all the way. Get the first part out. The struggle. And this is sometimes big pain in the butt. Just getting that first part out. There we go. Come on. Here we go. This is, if I can grab it, right here, this guy. All right. There are definitely more of them, so I'm just going to kind of set that aside. And then R19 is 47.5K. It's the only one on here. It's no 603, 47.5K. Okay, not in that collection of parts, but you could be in here. Wow, yeah. 603, nope, not in there. Got to be somewhere in here. Here we go. Here we go. Found it. 47K5. Yep. The only one on this board. All right. Now, this guy ripped out. And if you're watching the stream, again, all right, this guy goes here. If you're watching the stream, I appreciate it. Thank you very much. Especially if you've been checking us out regularly. I really appreciate that. So a lot of times I can just tell that I have somebody watching the stream, but it never shows me who. And that's fine. So if you're a regular, I really appreciate it. It's really cool that you've been sticking with us and checking us out. I think that's pretty cool. I hope you're enjoying it at least and learning something from it. As my goal is to teach as best as I can the knowledge I've gained over the years. Oh, I just made my situation worse. Much easier to do with the magnifying lens and... Alright, so got that guy. So right now, all that's left that I can visually see right here without inspecting under the magnifying lens are the TVS diodes and the transceiver. So let's see, I know... Okay, well I found the transceiver right off the bat. Let's see if I can find the TVS diodes. Here they are. Awesome. I use these a lot in other projects, so kind of, and it's gonna go flying on the floor. How fun is that? All right, you went for your little ride. Now come back here. So there are 1, 2, 3, 4 of these little guys on here. Good thing they're SOT 23.3. Now I will say this, that yes, before I get corrected and informed of this, before somebody, a keen-eye viewer catches it, yes, I should be wearing proper ESD protection. That should be an ESD mat and a wrist strap. And yes, you are correct. That is stuff I'm going to work on correcting as I move forward. But again, the idea of going from a hobbyist to, so I already do this work professionally at Sanctuary Software Studio. So, there's no real need for me to do it at home other than a hobby. But I also like doing it. So I like designing and building and doing this type of work. So it's kind of cool that my hobby is my job. Not everybody's fortunate enough to find that, and I get that. I just was fortunate that what I enjoyed as a kid was something that stayed with me through adulthood, and I was able to continue working with it and doing it. So I do feel fortunate in that regard. It's even funnier that I was able to, go to school for electronics engineering back in the day, and actually still do it. Able to find a job in the field. Although I've bounced around between multiple different industries because the market conditions and different things going on, as the industry, the .com burst and all the whole IT industry falling apart, forced me out of doing that. And the electronics is still a hobby, but I wasn't really that deep into it. It was just something I did, but my main thing was computers, IT. And then I got out of that, got into manufacturing and other avenues, and managed to land into electrical engineering work. So then my hobby took a greater interest in it. So this is the transceiver for the RS-485, the SOIC 8 package. Real easy to hand solder if you ever have to. I mean, all these parts on here, at least for these guys, even the transistor array, that's the dual transistor, even that's hand solderable. Everything on here can be hand soldered. So that is no longer needed for the top side. I have to go through and do better organization while this kind of cooks down in the oven. So I'm going to move my tweet kind of out of the way, kind of pull this up under here. So it's kind of like what I have, the 10x magnification light I picked up. Really handy. I don't know how well you're going to be able to see it, but I'm going to be able to use this to kind of get a better inspection of the part placement and do my best to kind of nudge anything that's too far off pad. Again, when it goes to the reflow, a lot of this stuff's just going to self-center due to the surface tension, but ICs and other fine pitch parts you got to be more mindful of, because sometimes if they're too far off pad, they'll actually go way out. And they'll sometimes totally slide in a completely opposite direction and go completely off pad. Part of this is just to minimize how much work I have to do by, how much rework I have to do. Okay. And the great thing about the paste is when it goes liquidous, it'll kind of correct itself a little bit. So some of the excess and the smears will just kind of get pulled into the fold. All right, that looks good. I have an easy view of this. Turn on the reflow oven. We're going to select a built-in profile. I think I use 6. Wave 6. All right. So okay. Move my paperwork out of the way because I don't want to complicate things. Get out of the way. Pull open the little handy dandy drawer. Place my board in here, roughly in the center. Let's see if I can get my webcam going again. Just because I thought maybe you'd get start the. See if I can refresh it. Boom. Try to get the right orientation. Again, my workshop. Things are still in flux. So the reflow oven. Got the little handy dandy tray. Just kind of show you real quick. So I do have it vented out. I won't turn that blower on because that's way too much air. And we're going to auto execute wave 6. And it's kind of boring, so what it'll do is it'll run through and start heating up with a lamp inside, an infrared lamp. Start heating the board up, following that curve. And then So let me move this light all the way. Wait, maybe I could show you, explain a little bit better for those who may not know reflow. Kind of important stages of reflow. And I'm a little jerky here. I'm sorry for that. So you have basically your soak stage where you kind of, or your warm up stage where you kind of bring your temperature up. Then kind of your soak stage right in here where it kind of slowly brings the temperature up so everything kind of gets up to the same temperature. And then you actually have the reflow stage, which is your peak right here. It peaks out. That's where your solder actually, everything goes liquidous. Your solder actually melts. And the actual reflow happens where it actually solders and the joints are made. And then you have your cool down stage. This is just as important as any of the other stages, your cool down. You don't want to bring the temperature down too fast. Or you don't want your rate of temperature drop to be too high. Because on larger boards or boards with a lot of copper in them, like multiple round planes, what can happen is the boards can warp and twist and cause some serious damage. So while that process goes on, I'm going to kind of shut off my camera off my phone. There's not much we can do while it reflows. It's going to take a couple of minutes. See, about 7 minutes, so we'll just kind of hang out together. If you're in the Twitch stream, feel free to chat. Again, this is going to be kind of a longer video and a longer stream than I'm used to because of what we're doing. Sorry for all the noises of me adjusting myself in my chair. Older chair. It's seen a lot of use in my workshop. So, see what my phone's complaining about. Blah, blah, blah. All right. So, it's been an interesting ride so far. A lot of different things going on. A lot of stuff we're doing. And a whole new format and something for me to do and try and work with the video stream and the recording of these tutorial videos. Again, I've never done that before, so it's been kind of cool. So what I'm going to do is I'm going to kind of, while I'm waiting on the reflow to happen, I'm going to kind of organize my parts over here a little bit better and get the okay. I know I won't need. Get the stencil put away from the bottom. That'll get that out of my way. Kind of set all the through-hole parts off to the side because we'll deal with them later. In this video, it's a surface mount part. That's kind of technically not a through-hole part. Still have to put the fans together. Maybe that's one of the things we'll do tomorrow, put them together. Because again, we're not going to, this video, this stream and the video that's associated with it is going to be long as it is. I mean, we're well over an hour. And we still have the top side of the board to populate. These in here. Yeah, and I'm going to tell you firsthand, if you've never been around it, solder paste is not pleasant to smell. It's actually kind of horrible. So, if you go to do this, yeah, definitely well ventilated. So I've got fans going on, and then once this thing is done reflowing, I'll definitely turn on a blower to help kind of pull out some more of the exhaust. So, put the bottom stencil away in its box. Back where you belong to keep you safe. And what I'll probably do is, if it gets to the point to where we get to that point where it looks like it's okay to build the additional boards for deeper testing. I might just build those off camera because that'd be way too long, way too much of a process, and honestly, I could work a little bit faster without having to think about doing a video and stuff. I'll be able to slam through it. So hopefully that all the initial testing is a success, and we can build. All right. Okay, get the top stencil kind of loaded. I'll kind of adjust its centering and stuff once I get the board's ready to paste up. Mm-hmm. Going through. All right. Doing his thing. Yeah, as soon as this gets done, I'll kick that blower on. It'll be loud, make a little bit of noise, but we gotta do what we gotta do to help, clean up the air a little bit. So that's that guy. So we did this. So while we're here, let's go ahead and open. Go back here. Project documents, yes. Project budget. Now, we're going to do might as well, because it's something I had to buy. 35. I'll have to go back and double check our. Do not, don't show again. I'm just gonna keep it the format you're in. All right. So there we go. So yeah, so the oven's entering its cool down phase. So let's definitely turn the heat off. Yeah, these can be nasty to work around. The fumes are just annoying. And in a full-scale manufacturing environment, they're even more pleasant. So we've got this variable power resistor. So I've got that coming in. So what I might do then is grab that. View, freeze rows and columns there. There, it's easier to see. So let's make sure we're actually, yep. So I was just making sure the things we're allocating up here, right? Got enough selected. All right, so that's the internal fan of that. Trying to cool it down a little bit more. But yeah, in an actual manufacturing environment, if you're on an SMT floor, it can be quite stinky if the ventilation doesn't work right. So we have that done. We're good there. Prototype build. Yeah, even though we could put that in maybe another phase for testing. Maybe we'll change that later. But for now, we won't. So go ahead and close that out. Save it. That guy coming in. Come over here. So, our initial test plan. Yeah. there's a lot of stuff we've got to take care of. Let's go ahead and oh, stop giving me these windows, these messages. All right, hooray, hooray for everything. All right. So this is basically what we're going to be working with. C2 dash, oops, 1. Space in there. Nope, no space. Okay, and then this guy. All right, so that would be the pizza's done. Now it's gonna get kind of noisy. I apologize, but I'm kicking the main blower on. And this thing likes to sing one heck of a tune. It's going to help pull more of the fumes out and help kind of pull the board down a little bit faster. Because right now I do not want to handle that board. It is going to be smoking hot. These I know are used. That 120 ohms. That I already used. The current sensing. That. Need that. Yeah, these are parts that only used in one spot. So set them aside. So when we go to the top, it'll be a little bit easier. I don't have to dig through those parts. Give that board a little chance to kind of cool off a little bit. Again, sorry for the noise. But while we're sitting here waiting, because I don't want to touch that board, it'll hurt. So we got that. So we have that. So yeah, one of the things we're going to have to do is definitely write some scripts and programs and ESP32 code stuff. We'll probably end up doing a lot of that here in the workshop. And do all that here. So I'm going to definitely want to get some more stuff set up over time to better illustrate and share the process with everybody. So we got that. Hot air gun with temperature control, yes. I don't know if we're actually using that here. Okay. So we might clean this up and get rid of all this. It's kind of get rid of all that double speak, kind of clean this up, make it a little bit nicer. Because we kind of got it spelled out up here. So we might be okay with that. There's nothing wrong with being more organized and having things look a little bit better. Yeah, show everything up over there. All right. That. All right. We'll clean all that up. Yeah, I'm hoping to be able to do this stuff, at least some of this stuff tomorrow. We'll see. Yeah, we got a lot of things to do before we can do all these tests. Wow. A lot of things. But the good thing is once it's done, you'll have framework for future projects. Let me see how hot this board is. Okay, board is no longer toasty. Turn off the blower for now. Turn this guy back on. I'm going to switch back to the webcam so I can show you what we're going to do here. All right. All right. Okay. So that looks like it's good. So what we're going to do then is kind of just do a precursory inspection with the magnifying lens. Kind of check all the solder joints. Yeah. Again, I don't know how well you can see that. I apologize. So we're just making sure our solder joints are good. There's no cold ones. The parts are centered. We don't have solder balls anywhere. No bridging. We'll make sure everything looks like it reflowed properly. So a lot of the parts did center and flow in. Again, I don't know how well you can see that because my preview window on my monitor looks one way. So yeah, basically I'm just doing a precursory inspection because now would be the easiest time to take this with a soldering iron and rework any of these solder joints if they look bad. But no, they look fine. Everything's looking A-okay. All right. Just kind of move this out of the way because I will need that for some top parts, especially to make sure I find the pins and everything for that guy. Oh boy. So here's something too to be concerned about. Looks like there was some solder paste here on the table and it transferred over here. I didn't catch it and it kind of reflowed. So I'm going to have to try to clean that up real quick. This is not going to be fun. That was a mistake on my part, but grab a wipey for now because I need to take care of that before we get too far ahead. I'll be grabbing more wipies here in a minute. A little bit of paste there, a little bit of solder there is fine. Doesn't look like it's a whole lot. I may have to skip. Well, I should be able to. Okay, good. That should paste okay. I'll have to just be mindful and inspect that much better. All right, well, I'm going to wipe the top of the solder stencil a little bit before I start aligning anything. Give it a chance to dry. Set that guy aside. Yeah, so let me inspect that under a magnifying lens. Okay. Yeah, that might paste okay. If I have to, worst case, I'll just hand solder that part. That's my fault. I didn't clean up the work surface enough and got paste on there. That was completely my failure. It's like a little bit of stuff is left behind. So, another good thing you can use. So in this pen, it's a flux pen. It's a flux dispensing pen for liquid solder flux. It's refillable. And I use water-soluble flux. But sometimes a little bit of flux as a greater solvent helps you pull stuff off of boards and stuff better than some of these other things. Because one of the key functions of flux is to clean. Now we gotta let that dry. Looks like I got it all. Get this lint off of the stencil. Which is okay. Got it. There we go. Get that lint off. Yeah. All right. Yeah. It's like the old days, the old game cartridges. You got to blow on them to get them to work right. Trying to get this the cleaner to dry up. And while we're doing that, let's kind of just make sure we don't have any paste left behind on this guy, because I don't want another one of those messes. Yeah, there's some paste there. Yeah, that was a mistake on my part. I wasn't paying attention. Yep. Okay, so grab my little towel, dry this guy off. I want to make sure we clean it better before we even bring the board out. We'll make sure not to make that mistake again. Okay, populating this shouldn't be too horribly bad. It'd only be half of a nightmare. Wait a minute, I'm gonna have to fix something. I have to fix one of the footprints like KiCad. So one of the things I'm going to fix in KiCad, so I don't know if you noticed, I didn't catch it till now, and that's fine. It's something I'd work around. Because again, this board will probably go through another revision. Is D3, the Schottky diode. I don't have any polarity indicator in there. And that is definitely got an anode and a cathode. And the cathode would be this side. Fortunately, we know that, but we'll fix that footprint. Maybe while we're waiting on other things to happen. We'll see. I'll just fix that off camera on my own time, knowing that I have to do it. Or maybe right before I upload, I'll just fix the footprint to have a line here to indicate cathode. Because it should be similar to like the LEDs. So it has the cathode indicator. Okay, I didn't catch that. No problem, no. We know the orientation. So the second verse is the same as the first when aligning it in the stencil. I'm not going to... There's no need to show the same process over again. So we're going to line this board up. And let's see. Wow. Actually, what I can do then is kind of loosen this stencil up and kind of arrange it. Move the stencil first, and then worry about centering it. There we go. All right. All right. Making a mess of things. There we go. Come on. We're almost there. Get the skew figured out. Oh, you're being a little pain in the butt. There we go. All right. If that isn't a thing of beauty, I don't know what is. All right. That should be good enough for government standards. All right. Okay, now. Second verse, same as the first. Grab a set of gloves because the solder paste is just nasty. Actually, nope. Grab another stencil wipe. Stencil wipe here because I'll need it. Right. Grab our glove. All right. Shouldn't have to worry about mixing the paste up because it's only sat for an hour. So it'll make less of a mess. Get the gobbledygook, put on the stencil. Gobbledygook. Or the cake icing, depending on how you want us to look at it. Yeah, it's getting close to me having to buy another jar of this anyway, so works out perfectly. And it's sat on the shelf, so solder paste has a shelf life. I haven't really looked too much into why. It's typically good for, I think, a year. 6 months to a year, depending. Okay. All right. Magic cake frosting is installed. Get the break. The stencil. All right. Move this guy out of the way. Bring it over here. Try not to make a mess of everything, but I always end up making a mess of everything. Okay. Kind of do the same thing. Inspect the paste. Unfortunately, underneath of a... All right. Should all work. All right. Beautiful. So, move that out of the way for now. Grab the messy stuff. And let's get the solder paste and stuff cleaned up, put away real quick. Delicious. And maybe nutritious, depending on how you want to look at it. Grab this guy. All right. All right. The first wipe. I know, super entertaining. And the cool thing is I'd be building this board even without doing this video stream. So, because it's still a project I wanted to do, I just thought, you know what? It'd be nice to share knowledge and do teaching. Get multi-win-win, basically. Get to share my knowledge, do some teaching, hopefully, and do a cool project. Hopefully, it can lead into many more. Okay. Clean the stencil off. That's a little nasty. Yeah, I'll clean this up a little bit. Fresher solder paste would be a little bit easier to clean. I can definitely tell this stuff's getting a little old. And clean the bottom side as best as I can. I'll squeeze out some of the juice and grab our toothbrush. And brush his little teethies. Because one of the things you want to try to avoid is solder paste drying and caking up, and especially there's really tiny orifices for some of these fine pitch parts. It's much easier to clean it all now. Clean it now while it hasn't dried yet. Everything's still fresh. All right. That can be set aside. I am done with the loud, annoying toothbrush. Take the gloves off. All right. Now let us populate ourselves a bottom side of this board. Or top side. My bad. Grab the bomb because we're going to need it. So let's start with... So anything that's in a moisture bag we'll do last because they're just a pain in the butt to open and reseal and all that. But we'll do all the passes and stuff like resistors, capacitors. C12. It's a 104. Find my big old supply of 104s. Now, let's see how many of these 104s we can take care of without putting this back. But, what is it? 12. Oh, okay. Okay, well, C6, which is up here, is a 104. And the next favorite thing to do, launch small chip parts across the room with a pair of tweezers. That's one reason you'd always buy extra. C5. Okay, C5 up here. Yep, there's C5. Yep, it's off of the other voltage regulator. 5, 6, 11. There's C11. By the ESP32. I think it's part of the enable circuit, the time delay. C11, C12 I just did, 15. I don't see it right away. That's fine. 18. So that could be on the bottom. So what I could do is I can grab a bare PCB from the stack. What I do? Where did I put the new PCBs at? I'm losing my mind. No, there they are. I can grab a new board and look at the bottom side and compare notes. Make sure. A little bit easier. See if C15's on the bottom. Yep, 15's on the bottom. 18's on the bottom. Here's where the fun begins. C20. There we go. C20. I found it. C20. C23. Okay. There's 23. All right. Four. Right under it. Cool, cool, cool. And another capacitor lost. All right. Oh, again. And of course, I have to nudge the one I just put down. Yeah. 25. Bottom, I don't think so. Nope, it's up top here somewhere. C25. Oh, there you are. All right. Good thing is these are like the bulk of them, of the capacitors, or the rest will be like onesies or twosies. 25 and 28. Where are you at, C28? Rather than struggling right now, there it is, C28. All right. All right, put this guy aside. Set these 104 caps aside for now, because who knows, I might need them for, I might have missed a couple, and that's fine. So let's go to C27. Let's find you. It's a one shot. 0603 474. Okay, wait, these I've already used. That is a part that'll go in later. Actually, I'll set that aside because I can probably do that next too. 603. Actually, I could probably do some of these silicone parts too, because these will be easy to shoot out. Okay. 657, 0603, 47405, AAAX7R. Found ya. And there's only one that goes on here. So this little one shot will be done. Hey, get out of there. C27. Seven. You're done. Set you aside. R28. Sometimes it's annoying. R28 is the 50K, 0603. 603. There we go. R20, make sure the part numbers. 0603, 50K. Yep. Another one shot. Struggling to get the resistor, the tape first opened. Flip over. Kind of comical, though, all that effort for one little resistor. One little fella, one little resistor. All right, then R29, which is the 30K. Good thing you're right here. 603, 30K, 075. Yep. All right. Again, all that effort for one little resistor. But unfortunately, the way it goes. Come on, little guy. All right, got that guy. Wait to do those because of where they sit, but what's this guy right here? This is the 203, the 3-volt regulator, which is part of this circuit up here. Mainly because it's easy to tell because I got the 3-volt, and this is the 203. So it's the 3-volt variant. Let's go and get this guy placed, this piece of silicone. Where was he? He's a little guy. Don't want to flop you around. All right. Okay, so polarity. Yeah, little dot small, but it's up here by the designator. Let's grab this guy. Let's find the polarity indicator. Oh, don't lose you. Hard to believe this little guy. This little chip is a buck regulator. And that little guy is a buck regulator. Pretty crazy. Pretty insane. But it is. So that's the 203. And here's the 205. Let's get it placed. Again, this is a big one not to confuse. Because, well, yeah, you can put 5 volts or 3 volts on the 5 volt rail. But you do not want to put 5 volts on the 3 volt rail. So you definitely do not want to get these two reversed. Okay. All right. And you want to try to make sure they're placed right the first time, because reworking them will not be easy because of how packed everything is on your board, on this board. Especially that inductor being right up where the pins are. Blech. Oh, I hate that. Oh, let's not make a big old mess. Come on, guy. There we go. All right. Yeah, the solder paste should get cleaned up. All right. Phew. You know what? And while we're thinking about it, let's go ahead and do the shot key. Get this guy peeled out of its tape. All right. Keep things isolated. So yeah, we know by default, because of the design, that your cathode side is over here. Let's see it, but there's a line on the diode. Okay, that's that fella installed. Okay. Now, let's find... Kind of start popping a little bit more around this guy. R1, which is 0603. It's the 330 ohms. Oh, 603 333. Let's see. 00758. There's actually two of them because there's two LEDs. These are the current limiting resistors for the LEDs for the 3 volt. I know exactly where these go in the design. One is for the 3 volt good, and the other one is for the status indicator. This guy is R32. All right. So we got that guy down. Another million parts to go. Hooray. Set you over there. So let's go and get the R2 for the it's 510 ohm, I think. I think it's a 510. You sure? And another one shot. There we go. My lint getting transferred over to there. Hands definitely aren't as steady as they used to be. Alright. That guy's done. Now, the inductors, which are fortunately the same, and I don't really need the part number to find them. I just need to know. I don't need those. I can set that aside. I know what that is. A temperature sensor. USB connector. Set that aside. Find the inductor. Here we go. Hey, another free extra baggie. I'll take it. Take another free Ziploc bag for parts. Good thing is we need 2 of these. I have to remember these smaller inductors. If this all works well, because I like these smaller sizes. The inductors I've been using for these type of projects have been kind of big. And these guys are a little bit smaller. I kind of like it. All right. Oh, was that somebody in stream chat, or was that another bot advertising? Oh. Welcome to the stream. So it's hard to see what I'm doing, or is it hard to find other people doing this on Twitch in the first place? Yeah, I don't know how many other people would be doing this on Twitch. That's why maybe I'll keep it up. Who knows? And yeah, if you're just joining the stream, definitely bear with me as I improve the quality and the work that I do with the cameras and stuff. Still getting equipment, still getting set up, still learning how to do this much better. So C1, C3. Let's get those guys populated. C1, C2, C3, C4. The 1206 big capacitors. The 1210. These are the 1206. 1206. 106, yeah, the 10 microfarad, the big daddies. So we need 4 of these guys. Fortunately, they're all in the same spot, or the same areas of the board. Kind of our like incoming bulk / filter caps. And I just lost one of them. Did I go bowling again? No, I did not go bowling, so these big guys right here. So what's kind of cool, something I've noticed with the YouTube channel, one of the viewers that has been interacting, that has been leaving comments and I've been replying to, is also an electrical engineering student from another country, I think Brazil as well, or somewhere else, I can't remember. I apologize if I butchered that, where you're from. So I find it interesting that there might be a lack, this might be a kind of kind of like a niche to help educate and teach others around the world, about this stuff. All right, so those are those big guys. Now let's see if we can get the output 9 and 7, 8 and 10. 7, 8, 9, and 10. Those are the big 12, 10 guys, and I just saw them. Here we go. Nice, big chunkus. The output bolt caps on the power supplies. All right. Yep, the bigger parts are definitely more fun and easier to work with. But mainly, we had to go big because we needed the capacitance value along with, the voltage handling value. I know those two LEDs for the power good indicators need to be populated, but I prefer to wait to do MSL, moisture sensitive devices last. Just because, again, once you start exposing them to factory conditions, the countdown timer begins on their exposure to moisture. So I want to minimize their exposure as much as possible. So like the 3 LEDs, D1, D2, and D9, we're going to wait to populate. So while we're over here, let's go ahead and do the opto-isolators for the inputs. These are easy to identify. So many of them I didn't even have to go and refer to the BOM. Sometimes when you get into parts like this, they kind of identify themselves, especially when you design the board. Or you've built enough of them, you're like, oh, wait, that's the optos. These do have a proper polarity of pin 1. Ugh. So if you're following along with this, it's probably a lot easier to kind of look at the schematic and or the PCB and KiCad to see what I'm, to reference to. Than to try to see what I'm trying to show you here. But so the footprint, the outline, there's a long line off of the 1 right above the 1 pin, and that's your pin 1 indicator. And I don't know if you can see it on the camera. I kind of hope you do. Again, I'm going to try to improve what I have to get maybe better zooms. But there's a shiny, don't want to get paste all over it, divot on the opto isolator to indicate where pin 1 is. So I'm going to rotate the board so I'm not reaching all the way across it to place the parts. Spin our opto around and start placing these guys. I really like using this particular Mega model for opto for one thing, the AC input is a really nice feature. Some designs, you've got to be limited on what you're doing, but for most things, AC input is great. Because it doesn't really care about the polarity. And then, again, consistently carrying the same parts modularizes your inventory and makes it easier. All right. Sometimes these big parts the population goes faster because they're just easier to place. You're not fighting them. Okay, now I'll get these guys put away. I don't want to try to keep everything as neat and clean as possible, as organized as possible. Bad enough I lost one of those big capacitors. That poor guy, I don't know. I think he ended up in Narnia by now. Make sure I don't have anything to worry about. complaining at me on my phone. I apologize. Sometimes it's hard to focus on just one thing all the time. Okay. So most of this is populated except for the moisture sensitive parts. We want to stick to all the small stuff. So let's do R31, which is that R31? R30? No, R31, not 32. Oh, R31. That is the other 1K that I knew was on here. 1K. That is the pull-up resistor for the tack on the fan. I almost remembered to be a 1K, but I wanted to double check. Hey, you're upside down. Not like it matters, but let's at least make it look good. When you invariably go up in flames and blow up on my face, at least you'll look good doing it, right, board? Okay, got you there. Okay, that's the last 1K. That's a big electrolytic capacitor. There they are on the box. We'll get to that later. Trying to do all these tiny little guys, these capacitors and stuff. R25. Let's get that guy populated. That is, looks like the 1 meg. R603, 1 meg. Yep, 1M. Okay. Oh, a different color. There we go. R25. You're a cute little blue resistor. Oh, look at that. All right. All right, C26. 0603, that's a 103 cap. 0603, 103. That's a 0.01 microfarad or a 10 microfarad. Or no, it's 0.01 microfarad, 10 nanofarad. It's easy to mess that up. Ugh. 10 nanofarad. 0.01, yes, okay. And that is, make sure I'm right, 26. Yes, sir. Okay, you're looking good. Sometimes a lot of the bigger, bulkier parts, like the big caps and stuff, it just populates a lot faster. Okay, C29, let's get you populated. That is 0603226. Is this 603226? 01, yeah, this is the other one that I knew we would need. This is a bulk capacitor for the temp sensor. Okay, while we're on that subject, I know that that's the temp sensor right there. So one of the things I might do is make little breakout boards for some of these products. Polarity is going to be a little bit easier because it's It's only a 5-pin. It's got 3 on one side, 2 on the other. So if you get that installed backwards, I don't know how in the world you tie your shoes. So all right, temperature sensor. Only a few more small components. Make sure I don't lose those. Those were not that cheap. Okay, so a resistor, a couple more capacitors to get placed. So R3, let's go and get that guy done. We're in the home stretch. Shut up, phone. Leave me alone. Sorry about that. R3. Let's find it. It is 603, 682, 6.8K. 603, 682, 0758. Yep. And it's also a value I use on picks. That's why I bought more than necessary for this project. Use it for a similar purpose for the master clear line on the picks to delay their startup. Basically, it allows you to delay the startup on the enable line of the ESP32 or the master clear line on a PIC 30 or a PIC to allow the power supply a full chance to stabilize. And we're talking like nanoseconds. It doesn't take that long for a power supply to stabilize, but you just want to give the microcontroller a chance to kind of, for that to happen before it boots up. C13 and 14 are hopefully they're the same. Yes, they are. 13 and 14. 0603 226. Oh. I probably threw them. Oh, no. I threw them in the done pile like a idiot. Thinking I was done with them. 0603. 13 or 14. Oh, yeah. Boy, I can count. So I need more than just 2. 603, 226. Yep. Boy, I can count. Okay, that's 13 and 14. I need 2 of these guys for that. All right. Oh, C21. I bet you're one of them. Perfect. All right. Okay, now I'm done with them. So there are there's only one TVS diode, and then the push buttons. I got those. I will have these capacitors to do next. Let me find the TVS diodes. I buried them too. But we're almost done with this fun, exciting portion of the video, which is populate parts by hand. Or other words, like I like to call it, pull your hair out and scream into the void. So the TVS, so this is for the switches. right. What is it? Snitches get switches? Alright, that was dumb, sorry. Alright, place you here. Yeah, that was dumb. I apologize. Yep. Aren't you glad you're along for the ride with me? Alright, so hey, I got another free baggie with the switches. Ugh. I'm dealing in other things other than electronics. Hey man, you want to switch? Come on. I mean, which isn't completely off base considering, you know, there are cannabis vapes, which are electronics, so it's not really that far out. Alright, come on. Alright. Get the little push button switches. Yeah, these guys are small, but I really like them because they do save space. And it's not like they sit here and perform super essential functions. They're cute little push buttons. They serve a good purpose and really safe space saving on especially more compact designs. Now, I'll put this guy on last. I'll put the USB connector on last because I have a tendency of smacking into that stuff when I go to throw it in the reflow oven. So, and that big capacitor, I'll put it on last too. So now that just leaves us with the moisture sensitive parts. So what I'm going to do, what is this guy? You know what, we can place him. So this is the motor. So I'm just kind of put you off to the side. Do I have my little Sharpie over here? Or I get dumb and leave it somewhere else? So let me grab a Sharpie from my workbench and a pair of scissors. Yeah, I was planning on soldering everything today. That was my original goal, was to do the reflow and then do the hand soldering. That was the plan, but we're already creeping towards 2 hours in the video. So what I might do is get the reflow done in this video and then do the hand soldering tomorrow and start some of the bench tests. That'd probably be the easiest, the best thing to do because we're running towards 5 o'clock, the 2 hour mark on this video. And yeah, I underestimated how much time it would take to actually build these boards by hand, especially a more complicated board. So yeah, so we're going to put the date in 1/3-26. Now timeout, we're going to round to the nearest quarter, so it's 4:30. All right, and then we're going to just mark on all the packages the same time frame because it all kind of comes out in the end. So I'm not going to worry about writing on the other ones. Kind of cutting, you know, as close to the original seal as possible because we got to reseal the bag when we're done. So this, where'd my tweezers go? See, it's cool is, again, these parts kind of self-identify. I don't need to look at the BOM to know what I'm working with here. This is the stepper driver I see. Oh, all right. Nice little chip. Big and complicated. Got the big exposed pad on the bottom. Again, okay. Get the polarity right. All right. So, just kind of nudge you. And that's why once we kind of at least go through the verification on this guy, and we feel confident enough to build more boards, I'll just build them off screen, off video. So before I get too far ahead of myself, okay, I need to nudge a little bit more towards me. That should be maybe just a little backwards, just a hair. All right, there we go. So reflow should take care of that. Don't need the extra baggie inside the baggie. Plop you in here. Back into the barrier bag. Kind of hold you over for now because we have more moisture sensitive parts to work with. That's the ESP32. That's kind of big. We'll wait. Let's get the LEDs done first. Here we go. These are the green LEDs. And we know these are the power good indicators. Green LEDs. I think these are 0603 in size. Yeah, I think so. So they're still small. But they're not as small as the 0402s I mistakenly worked with once. Those were fun. So I know I need 2 of these. Again, I'm not going to write anything on the static bag on the MSO label, so I'm just going to count it all at the same time. Because again, it all washes out in the end. Now, these guys, finding their polarity indicators can be a pain in the butt. And this camera is going to be very difficult for me to show you. So I'll try to explain it as best as I can and show you as best as I can. Oh, don't tell me you're even going to be worse on here. Oh, you are worse. No. Don't tell me you've got a chamfer. Oh, don't tell me. What is your polarity indicator, bud? Oh, you are not. Oh, don't tell me that's your polarity indicator. Well, you know what? There's a line on the bottom. And that does not make any sense absolutely at all to me. So I'm going to go get on Mauser. Hold on, let me get these parts pulled up, then I'll switch over. Show you what I'm doing. Q627 P5179. Okay, LEDs. I'm pulling up the data sheet. So I'm going to turn off this real quick, show you what I'm looking at. So I got the data sheet for these LEDs. Oh, they're 805 LEDs. Amusement, gaming, gambling. All I want is for you to show me. Are you okay? All right. So what it looks like, your cathode, little dot in the substrate, but it looks like the anode has less copper right here. So anode is a lead side with less copper. It looks like a little bit of that missing. Wow. What a pain in the butt. Yep. Okay. So that's the anode. The cathode is the full copper. Or the full side. Wow. I'll have to... Oh, no. Oh, boy. Wow. Okay. I'm trying not to damage the LED because the problem is the diffuser on them can be pretty weak if you're not careful. And you could easily tear these LEDs apart with just a pair of tweezers. It'd be helpful if I don't tear these apart. Really now? I'm just going to keep dropping you, so I'm probably being too gentle. Yeah, they'll survive the reflow oven, but they're physically a little fragile. And they can, like I said, they can be torn apart real easy with a pair of tweezers if you're not careful. All right. Wow. Okay. That's definitely an interesting one. Where'd the little bag for them go? I left it over here by the computer. All right. Yeah. Pull that up out of the way. Grab the red LED, which should be you, because that's going to be for the status indicator. And it's the same brand. Basically, it's the same LED. The only difference is it's red instead of green. So it should have the exact same polarity indicator. Helps if that stays behind. I don't need to be throwing that all over the room. All right. Wow. Red LED. All right. Perfect. That's D9. All right. That guy back in a static bag. Pull that over. Now, it's only a few more MSL, one more MSL, well, two more really. So we have the USB to UART interface chip. See, a lot of times this is cool, is they'll ship in these nice little black boxes, ESD boxes, when you order parts, individuals. Because I think these are in a waffle tray, a matrix tray. And they have to pluck them out of a tray. They're not tape and reel. So they have to pluck them out of a tray, and rather than leave them loose in a static bag or something, they put them in these nice little boxes. You just have to be very careful when opening them. So this is the Scilabs chip, the UART bridge. I don't want to lose the other ones because these are not low cost. Okay, these are really easy to see the polarity. Pin one's down here, and the chip, without even having a microscope, or a lens, I can see that that's pin one. Get that little piece of lint or cat fur out of the way. Come on, we're almost done building, guys. Come on, get out of my way. All right. Looks like it's gonna tap you down. Now, more likely that part will kind of float into place. Now we have a few last components. We can double check it. We have a couple components that are little love taps and reflow. And again, yeah, I was hoping to be able to do the complete soldering and work today, but because of how much longer this is taking than I anticipated, yeah, we're not going to be able to do that. Okay, some extra static bags out of the deal. That's cool. I like kind of trimming these cut tapes down for the ESPs because they just take up so much room. All right. So here's the ESP32 and a piece of cut tape. Again, this part kind of self-identifies. Come on. right. Get a little. Yeah, that solder mess down there should, during reflow, get cleaned up. So I'm not terribly worried about that right now. Throw that away. All right, so we have the USB-C connector. Grab one of them out of the bag. Really now, this is going to be stubborn. Off the cut tape. Set him aside. So this is the one that's got the staking holes, which will hand solder and, but that also makes it easier to place. Kind of centers itself, makes life easier. Now we have the fan, the JST connector, and then the JST connector. And then the large electrolytic capacitor, and then we can just double check, throw this in the oven and easy bake, and get this part of the journey done. Wow, look at that. Perfect. Oh, why I didn't I deal with the staples in this before this video? Oh, no. Ugh, staples in these little baggies. Ugh, I hate you. I hate you, staples. Get the big electrolytic out of here. Huh. All right, come over here. That's a new one. All right. Ugh. Okay. That red paint, that's where the negative side would be, just to let you know. So in here we've got the big old positive indicator. Getting a little twitchy there, huh? Alright. Gotta get you centered. There we go. Okay. So again, I'm going to take the magnifying lens, 10x zoom, kind of move things out of my way for a second, and kind of check over, make sure no part needs to be bumped, nudged, or whatever. Get some lint off of here, probably from the stencil wipe. Mainly looking to make sure like the driver micro is centered as much on the pad. Most of these parts should kind of pull themselves into place. All right. Okay. Those guys look good. Polarities are good. All right. Well, move this out of the way. That's the last thing I need to do is bump into that. Okay. All right. I'm going to select a different temperature wave. Three, four. I think it's four. All right, we're going to select wave 4 for the top, and we're going to do the reflow. All right, so kind of clean up a little bit while that reflows. Scratch an itch. Okay. Now, so we want to fill this guy out. We're going to say our time in, let's say 5 o'clock. We're just going to round up to the nearest quarter. So our total time right now is half an hour, 0.5. And that's what we're going to write on all of them. Move my tweezers out of the way. Get that out of the way. Before I clean too much up, I want to make sure that the MSL parts, the moisture sensitive parts, are put away. So I grab my heat sealer. All right, so I got the heat sealer. So as close to the edge as possible. It's good. You don't push out the air. You want air in here. That's the medium that the desiccant is going to use to be able to pull the moisture out. If you vacuum seal this, there's no air to transfer moisture. So you want to avoid doing that. Set that aside, and we're just going to rate the same stuff on all the parts. 4:30 p.m. P, yeah. 5. Kind of, and then do the same thing. Reseal as close to the edge as you can. Because again, we don't want to be eating into the time, because this part, which is the stepper driver, has a MSL level 3, and its time is 168 hours at factory condition. I haven't done the math on that, but you don't want to be eating into that. Because I don't know when we're going to be building the next boards. Okay. So down the road, we may actually have to invest in a small supply of the moisture barrier bags. Just for the simple fact that if we get larger quantities, like even this, the 30 may not use it up fast enough before we're through the bag. But what we can do is, as we get too low here, we can start cutting it from the side and do all kinds of funny stuff. There's ways around it. There's ways around it. So this guy, yeah, horrible handwriting. It's even worse on these static bags. But what's most important is total timeout. So this would be accumulated. So if this is another half hour, we'd put 1 hour over here. That's how we're gonna do it, just to keep tracking the time. So this heat sealer is not as robust as some of the higher end models, so I have to use it twice to get a good seal. But the main thing is to seal the barrier bag. And these, I think, are the Thylab chips. Smacking my camera around. Probably have been easier just to pull the parts out before doing this, but you know, I'm not one for thinking clearly sometimes. All right, perfect. So we can put these back in the box. Keep all our parts together. I'm going to put that PCB back in its box. And then I'll take some time to try to get better reference documentation put together, figure out how to do it in KiCad for assembly drawings, because sometimes that does make life a lot easier. Even if we have to go through and revise footprints, use some of the other layers. That aside. Put all my parts in here. Put my capacitors back in here. Yeah, the hand soldering, that'll go fast. We'll be able to zip through all that like no sweat at all. That's why I'm hoping we can get to some of the early, easy bench testing tomorrow. My mess. I don't want my cats coming in here messing with anything and getting hurt, especially off a pair of scissors or anything. Oh, there's my marker. It was where am I keep my flux pen? Imagine that. Put my scissors away. Okay. And yeah, I'm going to unload the stencil. I'll put it back in its box, put it in its storage location, because again, we don't want it getting damaged. That's the last thing I need is my cats prancing all over it and causing any damage. Getting their claws stuck in one of these orifices and damaging the stencil. That would not be pleasant. So that's not it. Printer. What's even better about this stencil printer is then for larger batch production, I'd be able to paste multiple boards at a time and run them through the process. Hopefully down the road we can get ourselves set up with some better equipment. Actually have a nice complete setup. I'd like to have a full SMT line, no matter how small, even with an actual stencil printer. That'd be awesome. So again, not sponsored by anybody, but hey, I'm open for it. If you want to help supply me with equipment, I'm game. I'm not opposed to it. Nudge, nudge, Juki. Neoden. All right. So clean up this mess. Maybe we'll also try to get that fan assembled tomorrow. I know we have a firmware we need to write for testing. A whole bunch of stuff. A huge process. Huge process. And one of the things I'm fighting in my head is doing this series. How much do I want to do off camera versus how much I want to bring you along with me for the journey? And I don't want to be too boring with these videos and these streams, but at the same time, I feel like you deserve to see the content, the process, everything that's involved, because if you're going to step into this type of work on your own, I think you deserve to know. It's more than just coming up with an idea on a breadboard with an Arduino or an ESP32 and just building board. Just a lot more involved than just that. It's time consuming. It's a monetary investment. Not only do you have to buy the parts, but you have to buy all the supplies, all the materials, all the consumables, and if you make mistakes, you're the one that pays for them, either with money or missed deadlines or something, depending on how you're doing things. So it's a lot to consider, and I think that's one of the values I'm trying to add to this video series and these streams is to show you what's really involved. It's not just 1, 2, and you're done. It's a process. There's a lot involved. And to do it right, there's a lot more involved. And that's one of the things I strive for, is to do it right. All right, so the oven is in cool down mode. So hopefully this board will be reflowed properly and I don't have to touch anything with the soldering iron tomorrow. I chose a slightly cool, slightly different temperature reflow profile. That gives a little bit more soak time because of all the bigger parts and trying to get that driver motor, the driver chip, reflow properly with all that thermal mass under it. As soon as this guy's done, I'll turn on the blower, pull out more of the fumes, and cool the board down a little faster. And then we can kind of give it a good look, see what it looks like, and hopefully it looks good. Yeah, I think having the black exposed is kind of a big mistake with the black chip resistor. So flip it over, go to gray. Eventually, I'll have green, maybe even blue, depending on what ESD mat. But I want to definitely get an ESD mat for over here. I like to get one that covers the whole workspace, but that may not be possible. So I'll just get one that at least covers where I'm going to be building boards. All right. Major blower. All right. Start pulling fumes out. And pulling cool air in to cool the board off. Oi. Yeah, so this was definitely fun about this is, these are the things I'd be doing anyway on my own time. I would be building these products, these boards. So I'd be doing this anyway, so it's just been kind of fun bringing you along for the ride. Here, test points. A little bit of through-hole work. That's fan. Maybe we'll try assembling that tomorrow. All right. Pluggables. These back in the box at least for now. I don't want any cats building anything behind my back. That's the last thing I need. Are the cats building a project behind my back? Oh, come on, board. Cool down. Wow. What are we, 3 hours in this video? Holy cow. I never expected this, never anticipated this. I will have to keep this in mind for the future. Hand building boards is time consuming. So I really appreciate you sticking with you guys sticking with me through the stream. I really appreciate that. That's amazing. Well, I really hope I'm providing some kind of value for you spending your time with me today. All right, let's see here. Aha, nice and cool. Not completely cool, but it's fine. Fan off. Reflow oven off. Boom. All right. So one of the things about these reflow ovens, another reason I chose a slightly cooler profile, is I don't know if you can tell on the stream. Okay. But sometimes it's plastic housing. The plastic housings on the JST connectors will get a little bit discolored and warped due to these type of reflow ovens. This is a limitation. I'm not going to argue against it considering the low cost and how easy and accessible they are. But I'm going to grab, again, I don't know how much you can tell. Maybe you can, maybe you can't. I don't know. I just kind of breeze through it. The ESP32 looks lined up. No bridging, no solder bridging there. The Scilab's USB interface, that looks real good. I want to be careful around this guy because even though it's soldered on the pads, I really need to get these stakes hand soldered in. So I got to be careful around that. I don't want to be ripping that off the board. That's the last thing I freaking need. The stepper motor, driver IC, everything looks like it flowed into place really nice. The capacitor. Another thing that'll happen too with these reflow ovens, if your reflow profile is wrong, if it's too hot, it'll just destroy these guys. It'll basically melt them down and they'll literally explode. The electrolyte will literally boil out and they'll explode. So that's something to be mindful of. So sometimes you have to play around with these reflow ovens to find profiles that work. That's why I like the conventional conveyor belt ones, the nice industrial, because they're so much better to control. Resistors look good. Yep. So I don't know if you remember, but the solder paste smudged on the buck regulator here, and all of it kind of cleaned up. Nothing's bridged. There's no solder balls or anything in there. Everything looks beautiful under the magnifying lens. So what happened here is everything looks like it's soldered fine. The buttons went on fine. I don't see anything wrong with them. They look fine. As far as I can tell. What's the button? Buttons push. Button push. Okay. Well, I don't know. Looks a little pasty. So tomorrow I might kind of touch that up with a soldering iron, kind of clean those up. But I think we're going to call it quits here because this video is over 3 hours long, something beyond what I was anticipating it to do. Some things I didn't anticipate the time it would take. So tomorrow what we'll do is we'll kind of touch up a few of the solder joints I know didn't look like they reflowed properly. Maybe it just wasn't complete in the center of the reflow oven. That's another reason I don't like these things sometimes. They do a good job, but at the same time they you can have hits and misses like that, cold spots. So we'll call it quits here. Thank you for checking us out. Thank you for watching the video on YouTube. And I guess you can actually see that. So I'll show you. So the boot, the enable button, and D7, it looks like they need touched up. Looks like it's a little bit pasty, a little grayish, not really nice and shiny like the rest of the solder joints look. So that was probably a dead spot in the oven. So it didn't heat up enough. But we'll touch that up with the soldering iron tomorrow. And we'll do all the through-hole work. And maybe start some of the bench testing. So thank you, and you're welcome. I appreciate you chatting with me, and thank you for sticking with this stream this long, and have a good rest of your evening, and see you tomorrow afternoon. All right. Boop.